Hello and welcome to another video on Booster Video channel. In this video, we'll talk about graded versus quantal dose response. Particularly, we'll talk about what's the fundamental difference between a graded and a quantal dose response. Then we'll try to understand this with the help of a hypothetical experiment or a data set. And then finally, we'll look at what are the major similarity and differences between these curves and their clinical significance. So typical dose response presents a relationship between a drug dose and response. So here is, as you increase the dose, you see increase in response. And this dose response provides you some important information, so like for example, this Emax, which is the maximum possible tissue response, and also this ED50, which is basically in this case is defined as the dose in which you see half of the maximum response. And you will see that the definition of this ED50 changes based on whether you're plotting this a graded dose response curve or a quantal dose response curve. So what is the difference? What's the fundamental difference between these curves? So the fundamental difference is that how you define response. So for example, in these two graphs, you see that the x-axis is the same, like in this case there's dose, increasing dose, the x-axis is the same, but y-axis in this case is defined as a response, and in this case is defined as percent responders. So based on this, this would be classified, or this would be a graded response dose response curve, and this would be a quantal dose response curve. So let's try to understand how. For example, let's talk about first graded dose response curve. So in this one, the response is basically something which can be measured on a continuous scale. So the meaning of that is, like, for example, let's say you are interested in assessing pain intensity, or blood pressure, or change in blood pressure, or if you are just looking at effect of a drug and isolated tissue preparation. I'm sure that if you have been in any pharmacology lab, you might have seen that you have an isolated tissue preparation and you're basically increasing the dose and looking at contraction or something basically. So you're assessing that how the response would change in relationship with the increasing dose. So that would be something, or the data would be plotted as a graded dose response curve. For example, let me just further clarify that. For example, let's say, take an example of blood pressure. So let's say, you're interested in that how a drug changes blood pressure. Like for example, if you give a small doses, it might not change the blood pressure. But as you increase the dose, it will decrease blood pressure, maybe 5, 6, 10, 20, 22, 25, 30, or whatever. So that is a graded response. So with the increase in dose, you're looking at a graded change in response. And in this case, the ED50 is defined as a dose which produces half of the maximum response. So let's see what's the quantal dose response then. So in this case, as I just told you, that the fundamental difference between this quantal and graded dose response is that how you define the response. So in this case, your response is basically a quantal or all or none event. For example, in this case, you might be interested in looking at like absence of pain, like what dose causes an absence of pain or absence of seizures. Or you define a response like, lowering the pressure by 25 mmHg. So, and you're interested in that, what percent of population will show this given response at what particular dose. And in this case, a dose or ED50 will be defined as a dose at which half of the individual will exhibit that specific response, whatever you define, like absence of pain, absence of seizures, or at least a decrease in 25 mmHg of the pressure. Let's try to take a hypothetical experiment and a hypothetical data set to understand how you plot these dose response curves and what's the fundamental difference. And in this, we'll take an example of analgesia. And then we'll see that how we are measuring analgesia in this case as the tail flick latency. So what is basically tail flick latency? I have listed this paper here. In this paper, researchers use this method, so you can go and further read it in case if you're interested. But basically, this is a method in which you can assess analgesic effect of a drug. Let's say you are a scientist, you discovered a new drug which produces analgesia or absence of pain, in other words. And then you're interested in assessing this dose response relationship. So use this tail flick latency method. So tail flick latency method is basically very simple, in which you take a subject like a mice or rat, and then you put the tail of that mice or rat on a heat source, and then you count how many seconds it takes for a rat to flick the tail from the heat source or remove the tail from the heat source. And then your hypothesis is that if you increase the dose of analgesics or inject the analgesic dose, whatever you discovered, if it is analgesic, it will basically cause that animal to flick the tail, or animal will take a little longer to flick the tail. So let's take an example, our hypothetical data sets. So we have to define what's analgesia. In this tail flick latency method, if the animal does not flick the tail in 10 seconds, we'll say that the animal has complete analgesia, or the drug is producing analgesia. So now, for sake of our experiment, we took 6 mice. You see that 1, 2, 3, 4, 5, 6, and then we defined 6 doses of that. Let's say it's hypothetical. 0 means you're not gonna inject that drug in the animal, but the vehicle or the solution that you dissolve the drug in it, and then you will take the baseline latency for all these animals. So you see that the animals flick the tail within 0.5 seconds to 2.2 seconds. And then what you did, basically, you started increasing dose of this drug, 1, 2, 3, 4, 5, 6, and then you, after a specific period of time, after injecting the dose, you tested the animal again using the same method, tail flick latency. So here you see that when you injected 1 milligram per kilogram, so this animal increased, little bit increase, little bit increase, little bit increase. Voila, this animal shows 10. So this says that this animal exhibited analgesia. So we cannot go for the 10. So it's basically 10. Then same thing here. It increased a little bit, but didn't go 10. Then you increase dose. Voila, there's another animal which basically acquired analgesia, and then so on. At 6 dose, 6 milligram per kilogram, all the animals exhibited 10 number or score, perfect score of 10. So I'm saying that at 6 milligram per kilogram dose, 100% of the animals achieved analgesia. So let's say I want to plot this as a graded dose response. So what would be the graded? So remember, the graded is looking at a relationship between increasing dose and increase in effect. So you see that there is increase in dose, there is increase in effect size. Or effect is or response in this case would be analgesia from 0 to 10. So if you take the average response or mean response here, see that this number is increasing, and this is the standard error of mean. So that's a graded dose response. And what would be the Quantal dose? And let's say if you want to plot the same data with using a Quantal dose response curve. So you have to define Quantal dose response. So in this case, I will define response is that I will consider an animal analgesic or the dose produce analgesia if the animal showed perfect response of 10. So if you see that at 0 dose, none of the animals showed 10. So this is 0. So at 1, there's 1 animal showed. At 2, there are 2 animals, and 3, 3, 4, 5, 6, and so on. So as you can see that there were total 6 animals. So and when we did not inject this drug, none of the animals or were responders or responded as analgesic. But as at one particular dose, you see that 17%, and then at 5 milligram per kilogram dose, 83% of animal exhibit a defined response. So in this one, our defined responder is showing analgesia, 10 perfect 10 score. So if you plot this, this will be like a graded dose response. You see this is basically these are dose, and if you increase the dose, there is increase in this graded number. You see this is the graded or average response. And then here, this is a quantal dose response in which the dose is basically plotted against what percent of animal they showed a defined response. We already defined response in this one at 10. So see that this is a fundamental difference between graded dose response curve and quantal dose response curve. So now you might be wondering that, well, can we plot a graded and quantal for any data set? Well, then it depends what you're interested in that. For example, as I told you that, if this is an event like a quantal, if this is a quantal effect event, like for example, let's say lethality, death, well, then death is either there or not there. So that's a quantal event. In that case, there cannot be a graded dose response. The answer is, or short answer is that it depends. So let's look at some similarity and differences between these two curves. So in terms of similarities, and both of these curves are important, and they provide critical information regarding potency and selectivity of the drugs that might help in making rational therapeutic decisions. But there are some differences as well. For example, in this graded dose response, as we saw that we plot increasing response against function of dose, but in quantal one, you plot rate of occurrence of a specific response in a population as a function of dose. Remember, we defined a response here, and here we're not defining, we're just looking at what response the dose produces or drug produces. Other fundamental difference is that you can study this in one animal or one subject, the graded dose response. All you have to do is increase the dose and you see the effect. So with the increase in dose, you see increase in effect. But in quantal dose response curve, you cannot do that in one animal or subject, because by definition, you're looking at the effect in a given percent of population, right? So this cannot be studied in one animal or subject. You need a group of subjects and animals. For example, we'll look at the same data set. So let's assume that you take only one animal out of whatever animals you want to look at it. So you see that one animal, let's take this animal. So you see that with increase in dose, you still see that increase in response. You see that? So this basically gives you the same data set like graded dose response, but can you make a quantal dose response only with one animal? No, because remember the quantal dose response was that you were plotting how many subjects or mice were showing that 10 out of that. So this is just going to give you one number or one data set, 1 point. So for quantal dose response, you need to have a group of animals. And finally, the critical information that graded dose response gives you is maximum efficacy of a drug, whereas the quantal gives you what's the variability of drug response in a given population. For example, if you took any of the animals, so you can definitely see that this produces 10, but when you plot this data as a quantal dose response, what you'll be wondering is that, okay, see this at this two particular dose, this was not producing 10 in these animals, but this was producing 10. So these guys are super sensitive, or at least more sensitive at lower doses. Whereas you see this guy took 5 milligram per kilogram, but did not produce 10. Whereas this guy just got 1, produced 10 milligram, produced 10 response. So this is a variability in the drug response, and that you will predict in a given clinical populations. So finally, let's look at how dose response can help you in a clinical decision making, or what's the functional significance of these. For example, in this case, this quantal dose response can help you to figure out a therapeutic index for a particular drug. So what is a therapeutic index? It's TD50 divided by ED50. So TD50 is basically a toxic dose, ED is effective dose. So if you divide this, whatever index you get, so that tells you the therapeutic index of the drugs. How greater is the therapeutic index, greater are the safety or margin of safety for that particular drug. So in order to explain this, let's take, we have two drugs, drug A and drug B, and you plot dose response for both drugs, both therapeutic effects and a toxic effect for each drug. So this is drug A, this is drug B. So you can see that the dose response for therapeutic effect and toxic effect are really close by, but in this case, the toxic effect dose response is way towards right compared to therapeutic effect dose response. So if you divide the TD50, which is this TD50 by ED50, in this case, you're going to get a larger number compared to this drug A. So based on this, you can see that the drug B is has a greater safety margin compared to drug A. So here are some relevant scientific papers in which researchers have used these terms that we just discussed, like quantal dose response or graded dose response, in case if you're interested in reading further. And thank you for watching the video, and if it helped you, do not forget to hit the like button. Subscribe to the channel for new videos.